Hi guys, so the question says to find the nodal equations for this particular circuit. Now, I'm going to be using KCL. KCL is basically at a particular node, the sum of currents entering to that node should be equal to the sum of currents existing in that particular node. And I'll be representing currents as V higher minus V lower, that's voltage, all over the resistor, all over the resistor that the current is passing through. So the first thing you want to do is that you want to identify the nodes. Before all of this node, this node, this node, this node, this node, this node, this node. But that's wrong. So that's how the first part. This is a node, but notice how here and here are just a wire, and here are just connected by wires. So there's no significant difference between them. It's just a wire. So all of them will have the same node V1 because they're just connected by a wire. At this position as well, you see this is all just a wire. Even this is just a wire. All of them are connected the same thing. You can literally eliminate all these wires and just join the components at the same time and still give it the same result. So this will be our V2. So there are actually only two nodes in this circuit. So at node V1, let's start with that. We're going to write our nodal equation. At node V1, all the currents are actually all exiting. You can see these 6 amps is clearly going downwards, clearly leaving that node. At this point as well, current will also leave this node. It will also leave at this point, and lastly, it will also leave at this point. So at this point, it exits here and here. Then at this point, it exits here. So the only current leaving this node, there's no current entering this particular node. So the equation is going to be 6, that's the 6 amps plus, for this particular one of 5 ohms, what is the node here? V1 minus, what is the lower node? This point is 0. This is ground, so voltage is 0 all over 5. You can just write V1 over 5 plus, for this particular one that's passing the 3 ohms, this node is what? V1 minus, what is this node? V2 all over 3. And lastly, this particular node is what? V1. This node is what? V2. So it's going to be V1 minus V2 all over 2 ohms equals to 0 because there's no current actually entering this node, so equals to nothing. Now I'll just multiply through by 30 to simplify the equation. It's going to come out as 180 plus 15 V1 minus 15 V2 plus 6 V1 plus 10 V1 minus 10 V2 equals to 0. And this is going to be 31 volts minus 2 V2 equals to minus 180. Now at V2, at node V2, so you're only going to be dealing with the nodes, nothing else. What's the current entering? This current is entering. This current shows that it is entering with its directional arrow. And at this point, the current will exit. But you forgot one more thing. This particular current, where do you think is coming? It's coming into this node V2. So this is entering, this particular node. And this is also entering as well. Remember, this is all V2. So it's going to be V1 minus V2 over 3 ohms for this particular one. Then plus the 7 amps that's entering. I don't need to write an equation because it's already current itself. And at this point, V1 minus V2 all over 2 ohms equals to, what's the current exiting? This point and this point. Now I'll just erase this so you can get a good look at this. What is this? V2. So for this one, it's going to be V higher, which is V2, minus when current drops across this resistor. What's this point? 0. So V2 minus 0 over 4 plus this one. This node is also V2. And then to drop across the 8 ohms to be V2 minus 0. The lower voltage is 0 all over 8. Now I just simplify the equation, multiply through with 24. This is going to give you 8V1 minus 8V2 plus 168 plus 12 volts 1 minus 2V2 equals to 6V2 plus 3v2. Simplify the equation. 20v1 minus 29v2 equals to minus 168. Now you notice that these are the nodal equations actually, but you notice this is simultaneous equation, this is simultaneous equation. You can solve simultaneous equations. V1 will now be equals to minus 2.56 volts, and V2 is equals to 4.03 volts. That's your final answer. Thank you for listening.